were closed. So we no longer have current flowing through this path. So I'm going to erase this to show that there is no current flowing through this path. Right, again here, no current will flow through this open switch. So it means we now have only two resistors involved in the circuit. Only RY and RZ. These are the only two resistors involved in the circuit when both switches are open. Right, the current flowing is now 1.3 amperes. Is now 1.3 amperes. So I'm going to change the current here to 1.3 amperes. Okay, so that is our new circuit now with the state of the switches changed. Okay, so it's basically two resistors that are connected in series. RY is connected in series with RZ. Right. They want us to calculate the voltmeter reading. They want us to calculate the voltmeter reading. It's going to be very simple because already we have obtained the value of RY, the resistance of resistor RY, and we are given the amount of current flowing. So I'm simply going to say the voltmeter reading will be current times resistance. Current of 1.3 multiplied by the resistance of RY that I've calculated here. Okay, 5.947. Let me use my calculator. 1.3 multiplied by 5.947. It's simplifying to 7.77 volts. That will be the voltmeter reading. That will be the voltmeter reading when both switches are open. Okay, right. Now we are given other information here. Switch S1 remains open. This is S1 that remains open, while switch S2 is now closed. So let me do that. I will close switch S2. Okay, and this one remains open. So we now have two resistors connected in parallel. Our current, when it gets to this point, it will be divided because now the switch is closed. But here, it will continue flowing through RZ. No current will flow through the open switch. So it's now a combination of two resistors in parallel and one resistor in series. Okay, right. So they want us to calculate the emitter reading. Obviously, the emitter reading is going to change. It will not remain as the 1.3 that we used before. It's going to change. Okay, so now to calculate the emitter reading, we first need to get the value of RZ. We need to get the value of RZ. Okay, how are we going to get the value of RZ? Okay, let's see what do we have to do there to get the value of RZ. Okay, we know the voltmeter reading. So we are just going to use the previous information. We have to use the previous information where we were told that current of 1.3 amperes was flowing through the circuit, okay, and we also obtained our voltmeter reading there. So I'm going to use, in fact, in electricity, you find that there will be so many formulae that you can use to get to an answer. So let me say V internal is equal to I times R, right? So when current flowing is 1.3 amperes, I want to calculate the V internal. The V internal, it will be the 1.3 amperes multiplied by 0.2. That will give us 1.3 times 0.2. 0.26 volts. So when both switches were open, that was the internal voltage. Okay, this V we obtained it as 7.77 volts. Let me keep it like that. Right, so when the V internal is 0.26, our V external will be the EMF minus V internal, which will be 12 minus 0.26. 12 minus 0.26. 11.74 volts. So the external voltage when both switches were open, it was actually 11.74. And we have already determined that the voltage used by the RY is 7.77. Right, these two will be in series. So if resistors are in series, they divide the voltage. So to get the voltage across RZ voltage VRZ, it will be the total external resistance, the total external voltage 11.74 minus the 7.77. It will give us 3.97 volts. So I'm trying to get the voltage across this so that I can calculate the resistance. So now I know that when the two switches were open, the voltage across this was the 3.97 volts that I obtained, and current flowing was 1.3 amperes. So the resistance of RZ will be voltage over current. That is voltage over current, 3.97 over 1.3. It simplifies to 3.97 divided by 1.3. 3.05 ohms. Okay, so that is the resistance of RZ. 3.05 ohms. So I now have the resistances of all the three resistors. I now have the resistances of all the three resistors. I can now go back to this situation where S1 is now open and S2 remains closed. And they want us to calculate the emitter reading. They want us to calculate the emitter reading. Okay, like I said, we have so many formulae that you can use to calculate that. I'm just going to make use of the formula EMF equals I R plus small letter r. Because we have the EMF 12, we also have, okay, current is what we want to look for. External resistance R, we don't have it. But already we have calculated all the resistances of resistor RZ, we know it. Resistance of RX, we know it. Resistance of RY, we know it. So we can actually get the what? Right, so all right, so here before I can substitute anything, let me get the total external resistance RT, which is going to be R P plus R series, because we have two resistors in parallel and one in series when this is open and S2 is closed. So for RP, I'm just going to use product over sum. Rx times ry over Rx plus ry plus the Rs. Okay, Rx I obtained there is 2.972 multiplied by Ry 5.947 divided by 2.972 plus 5.947. Okay, plus the RS, which is the 3.05. 3.05. Let me use my calculator to simplify. 2.972 multiplied by 5.947 divided by 2.972 plus 5.947. Okay, plus 3.05. It's giving me here 5.0317 ohms. That is the total external resistance, right, that we need to use here. Right, so my EMF is 12 equals the I that I'm looking for, right, multiplied by 5.0317 plus internal resistance 0.2. Then I can simplify to get the value of I. I'm just going to divide both sides by 5.0317 plus 0.2. This side as well divided by 5.0317 plus 0.2. This goes and I remain with my current being equal to 12 divided by 5.0317 plus 0.2. Right, the amount of current here I'm getting 2.29 amperes. That is the amount of current that will flow through the circuit when S1 remains open and S2 remains closed. Yeah, it was a bit of a tricky question, simply because most of the values were not available and so many things were being changed. At some point, both switches were closed. At some point, both were opened. At some point, S1 remained open and S2 closed. But I'm sure you benefited, and if you go through this presentation over and over again, you will get to understand the question much better. Right, thank you for watching the presentation. See you next time with another presentation. For now, it's bye-bye.